Hello, everyone. Its microphone's off. Hello. Lecture will be starting in a few minutes. If you're on YouTube, if you cannot see my screen right now, please let me know, but should be able to. There we go. Hopefully, YouTube people can hear me now. Welcome to the third lecture of Battlecode 2026. It's Intro to Bot Making. So I'm going to demonstrate how to make a bot. And this is going to include Java, and then at the very end, we're going to go over Python. And Python will be released extremely soon, most likely tonight. So it'll be exciting. But yeah, let's get started. First thing we're going to talk about is just basic, like how do you make the basic Java file or a bot. So let's pull up example player, which you've probably seen by now, scaffold. Once you clone the scaffold, yeah, wait, can the people on YouTube see? Yeah, it says share my screen. I think that's fine. Okay, cool, yeah. So here's the basic example function player, which you've probably seen. Let's first go through basically how this bot works very quickly, and then we're going to go into the actual bot making that produces like a more advanced strategy like this one. So let's get started.
Okay, cool. So the pretty much entry point for your robot program is the run method. So you'll see that this throws a game action exception, like most of the static methods that you'll be writing for your robot. Yeah, and inside of the run method, have some initialization code here. And then we start off with a while true loop so that your robot keeps itself alive and is always going to keep running code as long as it can. And then the actual bulk of our code, we have some string counting here. And then the actual operations that we're going to do are wrapped in a try catch. Because if you do actions that you're not going to be allowed to do, engine will throw exceptions, and so you'll have to catch that, or otherwise your robot will just die. Great. So, and then you should make sure to catch all of these exceptions, and then at the end, finish off the try catch block with a finally to make sure that you call clock.yield, which is important because this make sure that you go through. I guess some general notes on organization, as is just general good practice, you should make sure that you break up your code into smaller methods and call those methods rather than writing blocks of code everywhere. Yeah, and then the way that we're going to structure this lecture plan that we're writing today is so. Do you remember? Yes. Okay.
Yeah, so basically, the way it works is you have let's pull it up here. You have an enum up here. The enums are a nice way of organizing things like this. It just has these constant values, which represent basically what the robot's trying to do right now. You can see we have initialized line sheet, return to king, build traps, and explore and attack for this example. And what you do is you make a static variable. Everything should be static for Battlecode bots, by the way, called current state. Just set it to whatever your initial state is going to be statically right here. Use the state. You just have to, inside your while loop and the run function, reference the state value. You can do a switch statement based on what your current state is. Depending on the state of different things, it's usually divided into separate methods like this. And you should always make sure that this is just for rats because usually rat kings have separate states and then a whole different strategy. So you might want to make two enums or something. But yeah, I think we should start running lecture player. We have one here, but we're going to live code it again over here. So let's do this. Live code this issue. Yeah. View. Because I can't.
So we're just defining the enum for our states.
Sorry, I have a question.
Yep.
Why are the enums public? Is there any reason for this? Or
I don't think this is something, but this is just like, yeah, it's up to you what access you give it.
Oh yeah, one other thing to note before we make the state machine is it's a good idea to have your random numbers with a fixed seed. By doing this, double static random rand equals new random. Because like if you run the game multiple times, it's going to the same behavior. Otherwise, it would just be different because the but yeah, going back to the state machine, we just take the variable current state, which I talked about before, and then inside our try statement, we are going to want to have like a uh, catch game action specifically. So let's just copy it for the like player. And then inside try, we have a switch, current state, and it basically just completes all the code, which is nice. So here we are. Don't know why I said that. It's not working, but for now. So as you can see, you want to say when you initialize your bot, well, what state should you go into initially, right? It should usually depend on like a few factors, like the round number and the current rack cost. This is just because the current rack cost like identifies how many rats you have currently. So if you have more rats, you might want to do something different. You basically just set the state based on that. It's a general good strategy. And then you want to split the rest into methods. So we'll go through the methods individually and implement them all. Okay. Sure. Yeah. Yeah, we'll start with racking.
Yeah, so we're going to start by handling the case when our robot is a racking. Yeah, I mean, pretty much the strategy for this is that we're going to try to spawn rats in like random locations. And then one thing to note that is we're also going to write the location of our rat king so that other rats on our team can pull this from communication in the shared array.
Yep. So here's the basic racking functionality. The strategy I've implemented here is pretty simple. Don't know why it's doing that. Maybe it's using an old version. Oh, yeah. My autocomplete did not work this time. It worked last time though. Let me see. Build rat. And this is incorrect. This is supposed to be get all locations when radius squared. Yeah. So let's just electric player. So basically, when you want to spawn a robot, you look through all the adjacent locations or nearby locations. And radius squared of 8 is a good idea, but you can also adjust that. Put them in an array, and you look through all of them. This is pretty Battlecode intensive because you want this function there's a bunch of stuff. So if you want, you can optimize this by like selecting an individual location or direction to always try first, or some order like that. But this is just the simplest way if you're trying to get started. So you look through locations for each location, see if you can build it. If you can, you build it. And when do you want to spawn rats? Well, you spawn them when your cost is low, right? If you get too many rats on the board, your cost is going to be high. That's the incentive system for not having people spam rats all over the place. So you usually want to check something like this. And similarly, you want to check your rack has enough cheese, otherwise it might die. So you have something to check like this. It's good to have initially. Then, as Vincent said, we write the location tracking to the shared array. Since there's only one racking, it's fine. There's enough space for this, but if you want to optimize communication, we'll talk about that in the later lecture. This is good because rats have to reach back to the racking, so that allows them to find it. And then finally, we have this move friendly thing we're going to implement right now.
Yeah, we're just gonna start off by looking at what the current direction that's for the location right in front of the map is. And then if that location is like blocked by dirt, then we'll make sure to remove it. And if we can actually move them, then well, otherwise we're going to randomly start in a different direction. So then continue moving through. Yeah, I mean, we're also going to store, we're going to cache the array of like all the different directions that the rat can move in so that it can access this one we're picking a random direction to turn into.
Cool. So next thing we're going to do is implement the basic rat methods, baby rat methods. An important one is find cheese because like your rat king doesn't want to die, right? So let's do that.
I think this is pretty straightforward. We're going to read like all of the squares near us and then check if there is cheese on one of those squares and then go and grab that cheese if possible. Yeah, and then from here, once we actually pick up the cheese, then we should go and bring that back to the racking, and we're gonna reference, yeah, and then we'll switch states to return to rack.
Sorry, does this mean that a rack can pick up cheese on any of the 8 adjacent squares? I don't think the specifications actually tell us the cheese pickup radius, so.
Oh, I see. I'm pretty sure that it can definitely do that. The radius might also be larger. I can just check. I'll send out the Discord announcement. Probably update the spec if it's yeah. Curly braces are not working out. Oh, there we go. It's right there. Cool. So yeah, let's move on to the return to king method. Ideally, you'd want to use mining for this, but like that's going to be a later lecture. So we're just going to implement a basic algorithm.
So we will start off by reading off the location that we like wrote from the racking to the checker. And then we'll determine like what the direction that it is. So if we can turn towards the racking, then we will. If we need to like remove dirt along the way, then we'll do that. Yeah. And then once we get to the racking and actually give the racking the cheese, then we'll go back to finding cheese. And also I'll note that we're calling break here because these methods are being called again from our state machine. So this is necessary for our statement.
Do you want to do transfer? Cool. So now we've implemented most of the states, just 2 left. Build traps and explore and attack. Sometimes you might want to like combine these into one explore method, and then basically have like if you see an enemy nearby, build a trap. It's a strategy to use where you say like build wall traps around your racking. It's also a good thing. But for this lecture, we'll just do a thing where we're just 2 states. You're gonna build traps, you just randomly build traps everywhere. of the two kinds. And if you're in explore and attack, then you just explore. If you see an enemy robot, you attack. If you see a cat, you should attack. But I don't know if we. Yeah. I guess for cats, the main way you attack is to attack. So that's more this one. And then also, if you see an enemy rat, which you can carry a rat now, you should do it. So let's start with the Kindle traps. So let's do here. So far, we're just going to look in all of the directions, and then in every direction, we make a random choice as to whether we're going to place a cat trap or a rat trap, and then if that's possible, or a rat trap. And we'll also include like random tracks that we switch from to just explore. This isn't the method, so it's fine. Yeah. Just make sure. Yeah. Cool. So one state left. We want to explore and attack, and also potentially throw if the robot can, and carry if the robot can. So would you like to do that? Yeah. Yeah. Okay. Probably. Cool. So let's do explore and attack. Okay, Copilot is great. You should use it.
That is a lot. Wow. That's also a code. Wait, okay. Let me just write this right from scratch.
Yeah, so basically for the throwing, we're going to keep a variable called turn sense carry. And the idea of that is like, if you keep carrying a robot or a rat for too many turns, like you lose control of it, as long as we don't want this to happen. So the number of turns since you pick up a robot. And we do that so we can set a variable turn sense carry in your robot player. And then you want to check after a rat, and you've also thrown 3 turns or more. You can throw it. You could also do this for another something other than 30. So you get an idea. You can throw positionally attacking your rat. This is probably a good strategy. Throwing anything for us, right? That the right pickup. This you can pick up your own. You don't want to hurt your own. But in this one, we do check out. That's good. We're actually doing track that. But at least they're not actually that, so it's fine. So we basically look through all directions. If we carry that at the location, like then you should carry it for the strategy, and then you should attack. Yeah. So that's pretty much it for the strategy. And then you want to go back to the build draft state, some probability, just because in this algorithm we're kind of like having our be both probabilities and but you can definitely change that one of this interesting strategy. That's basically the whole thing. I think there's one error somewhere. Could we fix? Yeah. Wait.
Wait. Just
Probably. But since this is
probably
done,
from this
then
thing. Yep.
I think we're ready to try out this player. See how play this game.
It's very odd. Oh wait, did I?
Anyway, Java ES2
Okay.
Yeah. So deal with it.
Yep. I think it's fine.
Yeah. Of course, in order to increment that variable, the tracking reference is carry and set it to 0. I think I forgot some of my old code.
Oh yeah.
It should be there. Yeah. Yeah. Increment. It's not a tracking, then we want to do that. And then at the beginning, we want to set something large. I think I also made a mistake. Updated version of Electric Player is available on GitHub. I think it's private at the moment, but we're going to make it public so that all the reference for making your own thoughts. Injured on max values. Or that's over. Yeah. Cool. Anything else you want to say?
I think that's good. Yeah.
Yeah. So yeah, let's talk about Python for a bit, and then after that, let's just quickly run this on, see how it performs. So for Python, scaffold's not out yet, but the way it's going to work tonight is that's our C directory. You just make a folder with your bot name, Python. And then inside the folder, you put called bot.py. And then what you want to do is just import, or actually you want to do from import all. This is what it's going to be like. And then probably want to define, I think it's turn. Yeah, it should just be turn. This function is basically like run, except there's a slight difference, which is important. What we're actually going to have here is instead of having a while loop be inside the function, for Python bots, we already have the while loop existing in our code. And that's all you need to do is this inner part right here. You basically just run the single turn of your robot. And all your variables, they just be stored as global variables, I believe. So yeah, you should be able to do like, this example looks clear. So if you were to copy this algorithm here, then of course you have to do the random seed. So you want to do import random random.seed. Seed is, please don't use 42. Everybody uses 42. Then directions is the same, but for Python, I guess I should tell you like what the format of the methods are. It's going to be in the scaffold today, but the idea is like it's basically the same as Java, except everything's the same case. For all Battlecode, it's like RC.blank. They still do RC, even though RC is not a parameter, it's a global variable in Battlecode. So we do things like RC dot get snake case to get the round number. None equals this, and now you have the round number. There's another key difference, which is you can't just use print. Java. You can just use system.out.println in Java, and that's fine. But in Python, you can't use Battlecode because it doesn't work. You have to use log. We made it log, which will be available. So you just log something like this. And then everything else should be basically the same. We will have separate direction, application, classes, and all that. So the same syntax, but snake case. And yeah, I think that's it. Yep, should be everything. Stay tuned for the Python scaffold release. One more thing before we end. We're just going to run this lecture player. So let's open up the client. Let's go to command line. This is the good way. Of course, if you're in one of the IDEs, you probably saw how to do this in one of the previous lectures. But Gradle W update, and for Windows, Gradle W without the dot. Gradle W build. And then finally, we open up the client exe. Then we can let's do lecture player versus lecture player 2. Lecture player 2 is the one I just implemented with Vincent. So see what happens. You can open the console to I guess we didn't include any print statements, except for this one, but this is useful. There we go, that's better. Null pointer exception. I'll deal with that later. Yeah, Imagine still has a lot of bugs, but we're working on it gradually. There we go. It's all over. Yeah. Now we can play the games and see how this algorithm works. So you can see the rat kings are spawning rats. Do you want to do this? Yeah, okay. So the rat kings are spawning rats. Cats are being ignored right now because there's no strategy implemented for rats. The cat is actually attacking this rat king right now because there's also no defense against cats. Cats are like the biggest problem with this player. They do not consider them at all. So cats are the main reason why these rat kings die. At this point, she's picking up looks to be successful. Hopefully, I don't know what's going on with these, but like at least these are picking it up. And let me find a place where it actually screen. There you go. So if you look at the red team right here, the rats are going back in there. One just got chased the rat king, so it's working correctly. And now the cat is attacking the rat king, so the other team wins, even though the other team's not standing there. Let's see what happens with this one. There we go. So in this game, you can see they're actually deleting dirt. They're removing dirt, which is good, because when it brings the cheese back to the rat king, it should do that. They're not placing dirt. We haven't implemented that, but that could be pretty useful for your strategy if you want to like defend the rat king. Slow down. A bunch of cat traps. It's good that they're not in any kind of pattern. And again, we have failing. Which one is this? I'm actually curious. Lecture player 2. Okay, so that's the one we just implemented, which means the one we live code is as expected, but the one we didn't live code is actually working well. Cool. That's pretty much it for this. Yeah, anything else? Yeah. Thank you. Good luck making bots. We have office hours right here for an hour or so. Yeah, 2 hours, I guess. Do you have any questions?